So in the distal convoluted tubule, you're going to have calcium reabsorption that is uncoupled from the sodium reabsorption. So this means that if you use a thiazide diuretic, which affects this NCC transporter, this sodium chloride cotransporter, you're not going to affect calcium the same way you're going to affect sodium because these two processes are uncoupled. So there are two explanations for why a thiazide diuretic will actually increase calcium reabsorption. And so the parts of the nephron that we're going to be talking about here are the distal convoluted tubule, the proximal convoluted tubule, and the thick ascending limb of the loop of Henle. So let's start actually with the proximal convoluted tubule and the thick ascending loop of Henle. So if you use a thiazide, remember you're going to inhibit the NCC transporter in the distal convoluted tubule. So we're going to impair this transporter right here. This is not going to work. So what happens is you're not going to be reabsorbing your sodium. And remember, water follows sodium. So if you're not reabsorbing sodium, you're not going to be increasing your volume. You can also think of sodium equaling volume. So your body is going to become a little bit volume depleted because this sodium reabsorption is not happening, and that means that water is also not being reabsorbed. So now that you're volume depleted, your kidney is going to try to compensate for this volume depletion by increasing the activity of sodium reabsorption in other parts of your kidney, specifically the proximal convoluted tubule and the thick ascending limb. So what's going to happen here is you're going to increase this sodium reabsorption in the PCT and increase the sodium reabsorption in the TAL. And what's going to happen as a result is you'll have increased paracellular transport of calcium. And when you have increased calcium paracellular transport, you're going to increase the amount of calcium you have in your body because you're just reabsorbing more. So the first explanation for why a thiazide diuretic increases calcium reabsorption is because you are inhibiting this sodium reabsorption, so your proximal convoluted tubule and your thick ascending loop of Henle are going to compensate. And remember that calcium is coupled to sodium reabsorption in these parts of the kidneys. So since you're reabsorbing more sodium, you have to reabsorb more calcium as well. Now, the second explanation for why increased calcium reabsorption occurs with the use of thiazides actually can be explained within the distal convoluted tubule itself. So again, you're going to have this process where you are inhibiting this NCC cotransporter. And as a result, you're not packing in as much sodium within the cells of the distal convoluted tubule. So usually what happens is you're packing in a lot of sodium in here, and that's going to generate a little bit of a positive potential within the distal convoluted tubule. So when you're inhibiting this, you're not having this positive potential within the distal convoluted tubule. So normally, remember, you're having this NCC cotransporter pump a lot of sodium into the cell to create this positive potential. But if you're not having this cotransporter work anymore, what's going to compensate for that is this antiporter, the sodium-calcium antiporter, and it's going to start activating to compensate for this, and it's going to pack a whole bunch of sodium into the cell because this thing is not working. So think about what's happening here. If this sodium is going to be packed in via this antiporter, that means calcium has to be pushed out into the interstitium. So it means your body has to reabsorb more calcium in order to compensate for the NCC cotransporter not functioning. So in order to do that, it's going to start pumping in a lot of calcium into the interstitium, and it has to draw the calcium from somewhere, and so it's going to draw the calcium from the lumen via this TRP-V5 or TRP-V5 calcium channel, essentially. And so you're going to have more calcium entering the cell and then be sent out into the interstitium because this NCX1 antiporter is kind of kicking into overdrive to compensate for the lack of this NCC cotransporter and its inability to create this positive potential of sodium within the cell. So again, just to go over it really quickly, normally this is pumping sodium into the cells of the distal convoluted tubule, so this one is not working that hard. But if the NCC cotransporter is not functioning anymore, then this NCX1 antiporter kind of has to kick into overdrive, and so it's going to start pumping in a lot of sodium. And so the consequence of this pumping in a lot of sodium is that it has to pump out a lot of calcium into the interstitium. And the only way it can do that is by pulling calcium from the lumen via the TRPV5 calcium channel and across into the interstitium. And that's how we reabsorb more calcium in the interstitium. So there are two mechanisms. Either way you think about it, it should get you to the same conclusion that if you're using a thiazide diuretic, you're inhibiting NCC, and in the proximal convoluted tubule and thick ascending limb, you're going to have more calcium reabsorption because you're also going to have more sodium reabsorption. And in the distal convoluted tubule, you're going to have more calcium reabsorption because this antiporter is pumping more sodium into the cell, and as a result, it has to pump more calcium out into the interstitium.